Hello students, we have a problem in front of us, a polynomial of degree 3 with a leading coefficient of 2. There's 4 terms equal to 0, so we're trying to find all x's that give us 0. There's many ways to do this, but when I look at this problem, I'm thinking, if I can group terms together, maybe I can find a greatest common factor in that group. So I'm going to rewrite this as 2x to the third, and I'm going to take this term plus 2x and group these together. Then I'm going to take this term minus x squared and grouping it with -1. I'm wondering if you can see the greatest common factor in this group and what's the greatest common factor in this group. With this group, we have a 2 and they both have x. So the greatest common factor in this group of 2 terms is 2x. And what's left is x squared and 1. The greatest common factor in this group is, guess what? -1, which leaves us with x squared plus 1. As you can see, they both have x squared plus 1, x squared plus 1. What that allows me to do is to regroup it, this -1 with this 2x minus 1 times x squared plus 1 equals 0. As you can see, either this is 0 or this is 0 to make this true. So what does this x have to be to make this 0? Well, this 2x has to be equal to the additive inverse of -1, which is 1. So 2x has to equal 1. Or x squared has to equal the additive inverse of +1. So x squared would have to be equal to -1. To simplify this, we divide both sides by 2. And for this one, we take the square root of both sides. These cancel, and I'm left with x equals 1/2, which is your rational root. 1/2 is a rational number, or the exponent of 2 cancels with the radical, and so we're left with x equals plus or minus the square root of -1. This is a complex number, which is the same thing as plus or minus I. So our roots are 1/2, positive I, or negative I, and those are our 3 roots.